you can see it does have the sunspot and plus a few more. I do love pictures like this of the sun. I think the dynamism of the star has really shown up. So this is the, I can't actually remember, the Markarian's chain. This is a chain of galaxies, and these form part of the Virgo supercluster. So as you expect, they're near Virgo. I think the Milky Way's in the Virgo supercluster. Again, if I'm wrong, tell me afterwards. So there's several hundred galaxies. These two galaxies here are known as Markarian's eyes, and they're two galaxies that are interacting gravitationally. And the third picture is this really great picture of the Sunflower galaxy. Beautiful spiral galaxy, about 130 light years across, about 400 billion stars, comparable size to our own Milky Way and the Andromeda. Not a barred spiral. Which sits just down here. I'm going to say below Ursa Major, because I can't read what that one is and I can't remember it off the top of my head. All right. Sorry. One from Martin. This is the Spider Nebula, which is an emission nebula. Emission nebulas are nebulas that are heated up and become ionized and start emitting light, hence the name. It's about 100 light years across. It's a star nursery, which is contributing heavily to the heating up of the nebula. It's about 10,000 light years away, but it's in the opposite direction from the galactic center, so it's quite near the edge of our galaxy. Situated just here in just above Taurus. You know, a lot of the names, I read them, but I've never actually tried to say them. And you realise you can't. Peter does brilliant planetary nebula. And some of these planetary nebulas are what I think of as right on the cutting edge. They haven't been around long. This one was only discovered in 2009, which isn't very long ago. If you go on the web and look this up, you're pretty much going to find Peter's picture. It's not been imaged very much. Frequently, I cannot find the planetary nebula that he's taken a picture of. I mean, I can't find it with a telescope. That goes without saying. I can't find it in Solaris. And I trawl the net. This one, I actually think I did manage to find. So it's just above Puppis, or Puppis. Okay. If it's not above Puppis, this one don't tell me, because I'm feeling proud of myself for finding it. So this is a planetary nebula. He did this image. I've got to say, it's better on a computer screen. It's more definite. This is only like 403 arc seconds across, which is tiny. And he did it working with the Astronomical Society of Edinburgh. It's taken from a telescope he uses in Spain. I don't think it comes up very high in Britain. It's a bit too far down. So another one from Martin here. I love this one. So this is an old image that Martin said he reprocessed recently. I assume he's used more up-to-date software, and Martin's skills are very well honed and getting better all the time. So this is brilliant. Now this is the Pillars of Creation, and it's very, very famous from the Hubble picture just here. And I think this compares brilliantly. So it's part of the Eagle Nebula, which is near Scrutum there. And this is a cloud of gas. As you probably know, it's producing stars here. These things I discovered when I looked this up. These are known as elephant trunks, which I'd never heard before. But this happens, I think, as the nebula goes past the stars as they fire up. It's about 7,000 light years away. Okay, this one's from Richard at the back. That's come out slightly better than I thought. I apologise for the shakiness of the animation, because I did that. Richard took a series of pictures. This is the moon passing through the Pleiades, and you can see some of the stars get incredibly close. He's almost got the star going behind the moon. I love that. A couple more from Steve here. This is part of the Leo triplet. If you're wondering why there's only 2 galaxies, there's a third galaxy that'll be about here. These, as you might imagine from the name, sit in Leo, or just below Leo. Okay, they're about 35 million light years away. This here is Messier 65, this is 66. It could be the other way around, but I think it is 65 and 66. And collectively, they're known as the M66 group. This one apparently was only taken yesterday. The pinwheel galaxy, M101, is M101 or M5 if you do binary, is one of the most beautiful face-on galaxies in the skies. This one and the Whirlpool galaxy, always my favourite. This deserves to be someone's desktop. It's absolutely wonderful, but I only took it yesterday. Beautiful dust lanes, the spirals, absolutely wonderful shot of the spiral galaxy. Okay, about 21 million light years away. I think it's about 170 light years across, so a bit bigger than the Milky Way. Twice the size. Huge galaxy then. Okay, this, I think I mentioned this when we talked about Ursa Major, just up here. I think that's my last slide. That is the last. Has anyone got any questions? Okay, thank you.
Now, as some of you know, I always like to finish up our program with a very high-profile speaker, and that's what I planned this year, except he said he wasn't going to be available in June because he's attending an event at the European Space Agency, which will come as no surprise. I've known David Southwood for many years. Yeah, he's shaking his head. He's gone through so much that I hope you don't mind me referring to this reference. He has overseen the launch of missions as varied as the major gamma ray astronomy mission, Integral, building 2 instruments for NASA's James Webb Space Telescope, the Herschel and Planck observatories, as well as GAIA, the astronomical observatory that now has inspired a scientific publication rate faster than any previous ESA mission. In the solar system, he oversaw the arrival of Cassini at Saturn and the successful landing of the Huygens probe on Titan, as well as missions to the Moon, Mars, and Venus. So this talk will review some of his highs and lows, being the head of science for NASA, as he says, where it stops. Will you please welcome David Southwood?
Hi, good evening, everybody. Can you hear me? Yes. Okay. So, I think Jerry more or less gave my talk for me. Anyhow, I'm going to talk about my time as an ESA director. I was director of science for 10 years, marginally over 10 years, but it was quite the most exciting time of my life, and it was also a wonderful time for ESA. It was actually, if you look at the number of launches we had, it was actually the golden era. And that's because my predecessor did so much work, and I just drifted in and launched everything. So timing is of the essence. Okay, so I started in 2001, which I regard as a rather special year. And that's because I love the movie. But really, when I came into office, I had these spacecraft in operation. Basically, 4 big missions, and in fact, slightly more spacecraft, because SOHO and Cluster formed actually 5 different spacecraft. They were looking at the Sun and the Earth. And you'll see when I left, there were slightly more spacecraft. So just remember the number 4. Okay. What was promised in 2001, and if you like, my predecessor retired and left me with this commitment. And this is a slide from 2001 when I came into office. Whole set of just the astronomy missions that were published, that were promised, and I'm going to work through some of those. The first one is my first launch as a director. In fact, it was in early 2002, and what was very exciting about that is the place it was launched from. Those of you with a little bit of capacity in reading Cyrillic will know that's Baikonur in Kazakhstan. It's, of course, where the space age began. And what was really most interesting from an operational point of view is we were using the biggest rocket the Russians had at that time, the Proton, which was a military rocket. And so I had to deal with my staff who were able to live in a hotel that was in the middle of the military compound. And you had a choice then. You could either walk around the building and look at the barbed wire surrounding you, or you could ride a bicycle around. As a result, we would take the staff out every couple of weeks to the nearest town and let them get their hair down. It was quite a strange experience. I spent some time there. Very interesting. In the middle of the steppe, there's absolutely nothing you can see. The spacecraft itself was to measure gamma rays. That is the most extreme radiation, if you like, in the electromagnetic spectrum. And it's the only spacecraft where I went to the top of the tower before it was launched and wrote my name on the nose cone. The Russians do that kind of thing. And I can tell you, doing it in Kazakhstan, in Baikonur, the whole area, of course, had been used for military purposes, and the launch sites are kept far enough apart that if the Americans had caught one, they would only catch one launch site. So you just look, and just in the far distance, you could see the other rocket launch sites, and just it's dead flat and nothing there. It's a very interesting place, and I'm very pleased to have been there, but I'm very glad I don't have to go there again. So Integral was my first launch. It was the International Gamma Ray Astrophysics Lab, and there's a political aspect of this. It was jointly between the European Space Agency and the Russians. It had started off jointly between the Americans and the European Space Agency, and the Americans decided to change their budgetary arrangements, as they do, as you may have noticed earlier this evening. And they backed out, and they assumed we would cancel. They actually had an idea of what we were going to do with them instead. But actually, the Russians stepped in and offered us the launch, and we did it. So try and teach the Americans a lesson. They sometimes need it. I mean, I wouldn't make any political comments here, but so there you are, the International Gamma Ray Astrophysics Laboratory, very successful. It is more or less run out of steam now. So that was 25 years ago it was launched. Here's, to fit it into context, the electromagnetic spectrum going from radio around to the most extreme radiation, gamma rays, through X-rays, ultraviolet, visible, infrared, submillimeter, microwaves, radio waves, and at the time, putting integral up kind of filled ESA's coverage of the spectrum historically. They'd started and they completed it. Okay, well, I'm now going to show you what happened. There's a few more missions there, and they were in operation when I retired in 2011. So after 10 years, you can see what a busy time it was. There is integral there. Hubble, of course, was already up and still up. Newton, the X-ray astronomy mission, was live. Rosetta, Herschel, Planck, Mars Express, Venus Express, Cluster, SOHO, Cassini, Huygens. And then a lot of joint missions with the French, with the Indians, with the Chinese, and with the Japanese. I opened up cooperation with the Indians and with the Chinese. Politically hard with the Chinese, but at the time there were countries in Western Europe that wanted to collaborate with the Chinese. Now I think we feel differently. It's very frustrating. But let me tell you about my last launches as a director, Herschel and Planck. They were two spacecraft. They were built in a single project. It rather dominated my life. And you see the egg being eaten by a snake. I have to say, Herschel and Planck cost so much that they were the egg more or less breaking the skin of the snake. It was an absolute nightmare to manage. On the other hand, I think we did save money in the end by doing it that way, but you didn't have any margins, so you were endlessly having financial crises. I wouldn't recommend it now. On the other hand, the two missions, really, what I loved, Herschel, we had as minor partners the United States, NASA. And when we came to the International Year of Astronomy in, 2008, Herschel was NASA's mission for the International Year of Astronomy. It was our mission. It was our mission too. But Herschel really changed the infrared sky. It had the largest aperture telescope ever flown, 3.5 meters. And it, well, I'll tell you a little bit more about it. The next slide, let me just say something about Planck. Planck was also operating in the far infrared and almost into the radio waves. It was looking back at the noise left from the Big Bang. And it's provided us with the most accurate assessment of how our universe began. Interestingly, has justified the standard model of particle physics. In the structure that is left from the cosmic Big Bang, there are ripples. If you look at the spectrum of those ripples, you can deduce the manner in which energy has been transferred, and that, of course, is to do with the cosmic beginnings of our our universe. So Planck, they were not the easiest thing to build. They were both cryogenic because you're all radiating infrared light here, actually. You can't see it, but I assure you, at room temperature, everything radiates infrared light. So it's an absolute nightmare to build an infrared telescope. You've got to worry about stray light you can't see. But you're also going to have to cool the detectors to very close to absolute zero. And so we had complicated refrigeration mechanisms for both Planck and Herschel. But it hadn't been done before, so it was well worth doing. Here, actually, to show it constructed is Herschel. You get the scale of Herschel here. It is big. These are people here, full-grown men. And what they've done, they've put the whole thing together. They came in that little door there. And they're now wondering how the hell they get it out. Well, eventually they knocked down a wall and got it over the seas to Kourou, and it was launched successfully. But it's a beautiful. It really is a beautiful object. It was. That's its first image, M51. We had a reference to the Whirlpool galaxy, M51. That was just taking the cap off the telescope, if you like, and pointing it. It caused a diplomatic incident because the first thing that was done, it was clear we were going to get a resolution way beyond anything else in the past, improvement of around 10. And so my staff thought, well, what's the previous one? The American Spitzer telescope. So they got a Spitzer image of M51 and they produced a comparison, but it was far too embarrassing to allow that to go public. So instead, what you've got projected behind there is an image from Hubble, which of course is in a different wavelength and totally different issue. But I had to stop the appearance of the first attempt to compare Herschel's performance. It was absolutely magical to see this because you knew everything had worked. It was, and it's a little like that about Planck. Planck took much longer to really deliver the goods. From the minute we'd started looking with Herschel, it's a regular telescope. You just pointed at things and, it's no different from your telescopes you have at home in some regard, except it's responding in the infrared light. Planck was surveying the entire sky in order to pick up the cosmic background noise. So you had to wait for a year to get the first survey complete. That actually shows you our galaxy as seen by Planck. And all this had to be thrown away because what you're interested in, if you're looking at the cosmic microwave background, is this stuff that's painted orange in the way we've produced it here. And so we had to remove all of the stuff we knew about our own galaxy, all of the dust, which of course we had images of by other means. But it was a massive task and has been extremely successful. Planck is now the standard device for talking about the cosmic microwave background distribution in the sky. Jerry mentioned this spacecraft. It's called GAIA. This is It's the only mission I cancelled. I did it in 2001, partly because of an argument about my budget, and I was concerned it would not fit in the budget. It's a marvelous concentrator of the minds to have your budget reduced. And as one of you might know, what happened was GAIA suddenly went down in price by somewhere between 150 million and 200 million. I mean, I can give you the precise figure. It suddenly got smaller, it suddenly got less mass, and we could launch it on a Soyuz rocket instead of an Ariane 5. The remarkable thing was, it was largely occasioned by changing the way the optics worked inside the telescope, using skills that were developed for looking at the Earth from Earth observation spacecraft. Engineer who was based at, what was the company called? It's called Airbus now. It was called Astrium, it was called MMS. I mean, I have no idea. But it's not very far away from here. It has, in Stevenage, of course. It was part of it was actually the prime contractor was actually the French arm. But really, there was a single engineer at, let's call them Astrium Toulouse. I mean, I can't remember. It changed its name, so I don't know why would you keep changing the name of a company? Ask me later. His name was Frederick Saffa, and he'd been working in Earth observation. He was brought in to look at the optics on this. He said, "You must be mad to do it like this." And Saffa alone brought it within budget. It was brought back into the program and came in not so far removed from the price it said it was going to have back in 2002 when it came back into the program. It was actually finally launched in 2012, I think, after I'd retired. Okay. I don't know if you know anything about GAIA, but it is a remarkable thing. It's basically taken apart our galaxy, the Milky Way. It's measured 1 billion stars, which actually aren't all the stars in the galaxy, but a very large proportion. Beyond that, between 1 million and 10 million resolved galaxies outside our galaxy, 500,000 brown dwarfs, 300,000 extrasolar planets, 200 gravitational lenses, 10 million resolved binary stars, and so on. I mean, it really is a remarkable thing. It is now producing more astronomy as measured by the number of papers than any other mission ESA has ever had. It's really a major, major success. It's a data mine because it's collected the information about our galaxy over 3 separate surveys of the galaxy, and it's there for posterity. Just do the arithmetic. 1 billion stars. Think how much stellar astronomy you can do with that. Okay. Everything that moves. And the point is, it can measure movement. The next slide, I think I should have translated. The problem with having the prime contractor in France is you tend to have to give the talks in French. Now, I'll continue speaking English, but you could probably make up most of this, but this is very precise positioning plus movement, giving you the distance of everything in 3D, speed in 3D. So you're actually watching, you're actually taking the clockwork of the galaxy apart. Luminosity, distance and intensity, spectrum colors, which gives you the temperature and age of the star, and the composition, of course. It gives you the archaeology of our galaxy. Okay, I promise no more French, and I should have translated that, but as I say, it really was, in some respects, the magnum opus of my period of time. It dominated my astronomy. Oh, what's happened here? This is testing the sun shield, which is clearly not running. And there should be sound. There was, oh. Should I go back? Okay, I'll try again. Oh, that's right. And I take personal credit for noticing. I played the movie a lot just because if you're building anything mechanical to go into space, you really worry it's going to work. And so you test and test and test. So I had this movie given to me as the boss just to show they'd done it. And I played it a few times and I thought, I know a piece of music that is just that length. And it is. It wasn't playing in the room. Anyhow, there you are, 2001, very appropriate. Thus Spake Zarathustra by Richard Strauss. Okay, what about the solar system? I mean, that's taken you through some of the astronomical missions, cosmological missions. In 2001, going back to what we had then, SOHO and Cluster were looking at the links between the Earth and the Sun, and Ulysses was on a mission to fly over the poles of the Sun at about the distance of Jupiter. It went out to Jupiter and used Jupiter's gravity to go over to get into a polar orbit in our solar system. The first time that had ever been done. Not much, in other words. More was to come. In particular, the Sun and the Earth interacting. This is much more familiar now, really. The Sun exploding, sending things banging into the Earth's magnetosphere. Happily, we have a magnetosphere to protect us, which gives us, of course, the aurora, as you just saw a glimpse of. The Sun itself, SOHO, which was looking at the Sun, and Cluster was looking at the response in the vicinity of the Earth, had a coronagraph, and you can see how active the Sun can be with what are called CMEs, blowing out blasts of high-speed solar wind that The irony is, those are not going to interact with the Earth because they're going out sideways. You've got to see it coming towards you. That is something that's being dealt with at the moment with a new mission called Vigil. But anyhow, and then we had a small addition. The Chinese invited us to basically refly, if you had spare instruments that were looking at the aurora and so on cluster, to refly them in a pair of Chinese spacecraft called Double Star, and again focusing on the origin of the aurora. That was very exciting. It's the only time I've missed a launch because they decided, oh well, we're ready to go, we might as well go. I mean, the Chinese do things differently. I did get to one of the launches of Double Star, but missed the other. In compensation, they said, oh, well, you know, it's so good to have you here. We'll put you on the evening news. How many people watch the evening news from Beijing in China? I asked. Well, they said, well, we think it's around 600 million. It depends, because there's only one TV station, and the news, there's only one news in China. So that was a lot of fun. I had worked for the BBC when I was a student, and it resembled the BBC, except they didn't have chaps with guns on at every corner, in every corner of the studio. It was a bit different. But I'll tell you, we did a test run. I was wearing headphones and getting a simultaneous English translation of everything that came out in Mandarin. I was on with, I think, 3 Chinese scientists and a moderator. Everybody was talking Mandarin. I was talking English because I was hearing the Mandarin translated. So we did a good practice, all very good, and I think they asked me 5 or 6 questions. And I answered in English, and they were then immediately translated. And we were going to have the same script when we went live after the evening news in this sort of magazine program. I sat through the evening news, not really knowing what was going on. Then I'm on, there's bright lights. I've got my Chinese colleagues here. All I get in my headphones is Mandarin. Now I can tell from the moderator that he's talking to me. And I remember there were 6 questions. And so we're following the same script. And because I was the first, I assume they went through the 6 questions, and I could tell. Unfortunately, I mixed up question 4 and question 3. And there was a certain puzzlement, apparently, in 600 million faces. I found out about this the next day when my guide said, oh, I saw you on TV. I said, yes, it was really weird because I heard it in English beforehand, and then they did it, and I only got it in Mandarin. And she said, that explains why you started talking about your father. And it was question number 4 there was a reference to, you know, did you ever think you would be launching a spacecraft from China? And I said, well, you know, my father sadly is long dead, but I'm sure he never would have believed that his... Well, I gave that answer to question number 3. I've forgotten what question number 3 was, but anyway, everybody was happy. And I've never been asked back. Okay. So it was a record speed build for us. We did it in 2 years, which was really a record. So solar terrestrial physics has really grown following the work of various missions. The SOHO and Cluster were jointly with the Americans, and there's now really a new applied discipline called space weather. And you might think, well, what's space weather got to do? But we live in a society connected by electromagnetic devices. Probably, I mean, some things like radiation hazards to astronauts matter to astronauts, but probably not so much to us. But routinely, radiation, if you fly enough, you are flying in radiation that can be harmful to you. But probably the most important thing in my view, and people don't think about it, is the electrical power systems. As we move over to electrical cars, we're going to have to double the output of our national grid. It's going to be much more, let's say, in jeopardy from electromagnetic threats from the sun. It's not something we talk about a great deal. The national grid, I'm happy to say, do worry about this and indeed have plans for mitigation. So there's a whole field of worrying about the impact of the sun on the Earth and on electromagnetic systems. Okay, in 2001, what I was promising was a lot. I wasn't promising it, I inherited it. But landing Huygens on Titan, orbiting the sun with something called Solar Orbiter, sending something to Mercury called Bepi Colombo, sending something to orbit a comet called Rosetta and land on a comet, Mars Express, and Smart 1 to go to the moon. All of these things were successful except for one, Beagle 2. And yet, in some sense, I think Beagle 2 was remarkably successful. Certainly showed many Britons that we could do things other people couldn't do. And I'm absolutely sure that was psychologically extremely important for us. And indeed, I suffered a great deal from the launch, from losing Beagle. It was all blamed on me because I'd taken it to Mars, so obviously I was responsible. That's actually me at the launch site in Baikonur again. I got to go to Baikonur quite a few times. And you see the railway, that the rocket comes out of the assembly building horizontal on a railway train. The company's called Cosmotrans, which I absolutely loved. So all the engines and everything have Cosmotrans written across the side. And you walk with all the people on the project along beside the train until you get to the launch site, and then it's cantilevered up. And you can see the fuel waiting there. Amazingly, it was unfueled at the time, of course. I could just stand there in the middle of the rail track. I knew another train wasn't coming, but there you are. Okay, well, Mars Express, actually, you'll hear, had some successes, but it also had Colin Pillinger, who I'd actually known since Apollo days. We met on the BBC coverage of Apollo back in 1969 or 70. If you've ever wondered about why, anyone here worry about Colin's hairstyle? Here's where he got it from. That's Charles Darwin. I mean, you see the connection. I never actually asked Colin about it, but it seemed so obvious, it didn't seem worth asking. Anyhow, he really performed miracles, and indeed so many things on Beagle worked. That is actually the last picture I had of Beagle. When it left, it was precisely on target. We knew that because we could watch it leave Mars Express, so we knew exactly where it was going. Of course, we lost it on Christmas Day of 2003. And we never saw it again until it was discovered by some scientists at Leicester University, which is somewhere near here. If you live in Wimbledon, it seems to be somewhere near here. I'm not sure quite where, but it's the north somewhere, beyond Hitchin, I think. And they found Beagle 2. I mean, it was an immense discovery because I had been convinced the failure was in the parachutes. And the reason I thought that is that we changed the design of the parachutes at the very last moment because Beagle turned out to be heavier than it was supposed to be. And initially it looked like it couldn't go at all. And then some German friends of ours came up with some new material. Colin was able to do one test in Arizona or somewhere in western United States. I think it was Arizona, New Mexico maybe. And that was it. Now I have to say, when you're in the space business, you don't test things once. You test them over and over again, but there just wasn't time. It had to be launched on the 2nd of June 2003, and it had to be in Baikonur. So it was tested, and indeed successfully tested. But I was extremely nervous about the parachutes, and I assumed it was the parachute that let us down. It wasn't, because you can find the parachute now on the surface of Mars. And Beagle got down. In fact, it was clearly dust, which prevented the third solar panel opening. There were 3 solar panels to open on the ground on the lander. Unfortunately, the one that didn't open was the one that had the antenna wrapped around it, and so it couldn't phone home. Extremely sad. It was found in 2015, in January. Sadly, Colin died in May 2014. Extremely sad. In other countries in Europe, Mars Express is seen as an extreme success. It's still operating now. It introduced stereo vision. That is, vision like your eyes. Stereoscopic vision that allowed you to play with the morphology, to look at Mars in a different way. Look at it in 3 dimensions. I have movies that are like being in a helicopter as you fly over Mars, created by this stereo camera. The first images came out in January 2004, and there I am with the German minister, who was very angry with me until she saw the images. They were stunning, and they had this 3-dimensional quality that you get by using the stereoscopy. We discovered things fairly rapidly. This is on the North Pole of Mars. That's actually water. It's water ice. And there's a rime on the edge of the crater. This is a crater that doesn't get the sun. It's on the North Pole. You see the rime around the edge? That's CO2, dry ice, solid CO2, which is also white when it's solid. But the stuff in the middle there is water ice, actually on the surface of Mars. We also discovered water under the surface with a radar, which also made my life a misery. And it's so painful for me, I've cut that out of the talk. And also because my wife said the talk was too long. But anyhow, it was really, Mars Express changed the history of Mars. There was a French instrument called Omega, which discovered large amounts of clays that showed Mars must have had a very wet history at the beginning, and probably half of its surface was covered by an ocean, a single ocean. And that has changed the history of exploration of Mars since. The reason Curiosity is where it is because of the discoveries by the Omega instrument, the French Omega instrument on Mars Express. We did something else. Having built Mars Express, we built a kind of, not quite a clone, but something very, very similar in record time. We built it in 3 years, Venus Express. Mars Express had been very cheap. Venus Express, well, I hate to say it for somebody who worked for the company here, but really we drove a very hard bargain with them. And they were desperate for the business, to be honest. Anyhow, Venus Express, I won't even tell you how little it cost me. But Venus Express, again, very successful, and again the first light. This is the first 2 lights. We're looking down on the pole of Venus. This is in infrared, and it's the night side. And the night side, Venus is actually very hot, of course. The night side is radiating in the infrared. The day side is radiating on reflected using sunlight in the ultraviolet. This particular picture lays out before you the circulation system of the Venus atmosphere. It's actually the one you quite likely learnt at school for the Earth. Did anyone learn about Hadley cells in geography? Oh, gee, education's fallen apart since my day. But a Hadley cell describes how heat and indeed mass move from the equator to the poles. And it sort of goes over, it's like an overturn. It's like cooking. You know, it's heated from below at the equator and it turns over. That actually is only true partially at Earth, but at Venus you can actually see these things that rotate around are actually also turning over. This laid bare a single Hadley cell in the northern hemisphere and the southern hemisphere. That was effectively the first images. Really great. Okay, I'm going to move on to another planet, to Saturn. Cassini Huygens. This was very close to my heart because I'd been involved in Cassini since 1982, the very beginning of Cassini. And I built the magnetometer for the Cassini spacecraft, the NASA spacecraft. But I found myself in charge of landing Huygens on the surface of Titan. Kind of fun job, but a bit nerve-wracking. Particularly if you've lost in the public eye Beagle 2 immediately in the year before. So I was extremely nervous, especially about parachutes. Huygens had 4 parachutes that had to work. This was the great relief. It's the coastline underneath that emerged as we came through the clouds. We'd no idea what we were going to find on the surface. We designed Huygens to float in case it ended up in a methane sea. In fact, it landed on solid, I would say terra firma, but Titan firma. And look at these sort of dendritic structures. They're rivers. Oh, they're actually river valleys. It's not clear they're carrying liquid methane. So that emerged as we came through the clouds, and I thought, thank God for that. It doesn't matter if you don't get down to the bottom. Look what we've discovered. This was one of the early images. I'm English and therefore at school or at least when I went to school, since you didn't learn about Hadley's cells, I don't suppose you learned any poetry, did you? Anyone learn poetry at school? Well, it was a form of torture subjected to somebody as old as me, and you all look much younger than me. And this was the only thing that could express my feelings. Then I felt like some watcher of the skies when a new planet swims into his ken, or like stout Cortez when with eagle eyes he stared at the Pacific, and all his men looked at each other with a wild surmise, silent upon a peak in Darien. It's about the crossing of the Isthmus of Panama. It was written by somebody called John Keats. It looks like some of you need to know he was a poet about 200 years ago. And I know that now. Unfortunately, I knew the poem because I'd been forced to do it at school. And I'd often wondered about feeling that way. That expressed how I felt, so it was magic. Unfortunately, I attribute it on live television to Percy Bysshe Shelley. It's a way of improving your hit rate in email. Okay, so I better start finishing now. What was the biggest disappointment of my entire time? That actually is something that even rings today. Mars Robotic Exploration Program. In 2008, I was changed from being Director of Science to being Director of Science and Robotic Exploration, and I had to pick up a robotic exploration program which involves, for instance, a mobile lander called Rosalind Franklin now. Where could the program go? It was in serious trouble. And I did a deal with the Americans. They're very nice people to know for a while. But you can go to Mars every 2 years. And they were running out of money. And so I came and said, we invent a program with a long-term goal of bringing samples back from Mars. That'll give us a reason. First of all, it'll tell us what to do because we've got to practice, we've got to show things are possible. And over 15 years, we should be able to have the confidence to do Mars sample return. They agreed, and it got us an American launcher for what was to be called Rosalind Franklin. But there were whole things we agreed to do: landing, roving, drilling, search for life, network, etc. And we had nice pictures of it, and even a slide from 2011. Mars exploration, a human endeavor. I mean, you get very pompous if you've recited poetry on the television, you know. It's very dangerous. A human endeavor to be done by American and European robots from now on. This was, I had a very good agreement with the my American equivalent, the Associate Administrator for Science, Ed Weiler. And really, we had a meeting, we had a dramatic signing of agreements and so on. I retired in 2011. Ed Weiler retired shortly after me. By 2012, President Obama's White House had cancelled the whole thing. It was, that's a paper written by me in Nature, I think, when international partnerships go wrong. It had taken me 3 years to negotiate this with my American counterpart. It looked to be the way ahead. Everybody thought it was brilliant. And I have to say, it's a major disappointment because, frankly, we switched to the Russians. What did the Russians do? Well, I won't tell you, you probably know. So we're not going to launch with the Russians. We've gone back to the Americans. And what did the American government do? Reduce the science budget. I don't know when Rosalind Franklin will go. Okay, well, that was my biggest disappointment. I'm really disappointed about that. Very sad. What was the worst moment? Well, actually, this is the worst moment. It's the release of Huygens. In 2003, I've been accused of losing Beagle, although it went exactly where it was supposed to go, as we know now. The last thing I could even think about was losing Huygens. And at the same time, you see what you did to the mothership. The mothership is to twist around, turn away from Earth. You've then got to get it pointing back at Earth. Even more important, when you've got it pointing back at Earth, it's actually, as it's shown here, following Huygens. Where would it end up? It would end up on Titan. You do not want the mothership on Titan. So we then had to adjust the orbit to just take it over Titan, and yet slowly enough to be able to act as the communications means with Huygens. Anyhow, all that worked out, but I'll tell you, that was the worst moment, the most nerve-wracking moment for me, and you can probably imagine why. What was the best moment? Well, actually, shortly after the worst moment. It was looking through the clouds and actually seeing that we were actually landing somewhere with a map that was worth looking at. The rivers, the valleys, the mountains of Titan were below us. Immense relief. Then did I, like some watcher of the... Oh no, you've heard that. Okay. So, lastly, what was my favorite image? I never dreamt I would be building spacecraft that would go and visit things. I mean, I built astronomical telescopes as well, but what really excited me was the idea of spaceships and approaching alien objects. And this is my favorite image. You may find it rather dull. It's actually Rosetta photograph. It's a selfie by Rosetta. Here is the solar panels. The actual body of the spacecraft is up there. It's sort of dark. And this is Cheremov-Gerasimenko. This is a real photograph. It's not faked. It's actually taken by the navigation camera on Rosetta. For me, that's kind of magical. Happy, and I have to say, it somehow reminds me of my favorite movie. Afterwards, you can guess what that is. Okay, so that's me, Director of Science at ESA from 2001 to 2011. So, thank you.
Do we have any questions, firstly, in the room? Yes.
Alistair.
From who else?
It was Astrium, you're right, by the time we actually signed the contract, though we were speaking to you before that. And so...
it's very confusing, you know.
Well, we actually we transferred from being MMS to Astrium in 2000.
Oh, okay.
So that was the problem there.
Okay.
And by the way, have you actually met Nikki Fox, who is now the science lead in NASA? She was educated in Letchworth, St. Francis School.
She was born in Hitchin.
Yep.
And she went to Imperial College. She's a graduate of my group.
Yep.
And yes, I still have contact with Nikki Fox.
Well, you can see my interview with her on the BIS
Oh, really?
website.
I'll look forward to that. Yes. Nikki is sort of somebody who's done even more than me. It's very depressing about your students.
Do you think humans will get to Mars within any of our lifetimes here?
Sorry?
Do you think humans will get to Mars anytime soon?
Well, I think we've got to rely on Nicky Fox. Okay, I mean, it's a joint with the Americans now, and I'm not sure. Mars is very interesting for the future because obviously Elon Musk wants to go there. And and he wants to take people there. I don't think I particularly want to go on one of the early flights. I'm not actually sure I want to go at all, but it'll be interesting. At the minute, it's going to be very interesting, if not a little depressing, for some of the aspects of the changes I expect to come. But we'll see.
I've made a very strong argument that there is no way that Starship will send 100 people to Mars. It simply does not have the payload capability, and Elon Musk should darn well know that.
Can I ask you then, going on from that, what's your attitude to human spaceflight and the amount of money that's spent on that and the cost of that? Looking at the great science that's done by the probes that you've overseen, would the money that's spent on human spaceflight be better spent on robotic and other probes?
Yeah, that's an interesting question. It's a bit like saying, how many hospitals could we build with the money? I find it in the same class of question. Human spaceflight costs a large amount of money. It's a tiny fraction of the US budget, for instance. And of course, they're going to get much more wealthy. So, I just don't think, I mean, first of all, you don't do human spaceflight entirely for science reasons. You can do some science, but it's something different. I worked on the BBC coverage of Apollo, and I thought I was totally, taken up by the thing. It was so exciting. I worked for the BBC coverage of Apollo 13. I thought the 3 astronauts were heroic. Tom Hanks, Jim Lovell was particularly heroic, and but it wasn't science. In other words, you're not comparing like with like. So the short answer is, I am not against human spaceflight, as long as you don't think of it as being done for scientific purpose. There is science, but it's done for other reasons. It's done because we're human beings, and we like to see human beings out on the final frontier, on the very, it's just a different thing. And I wouldn't bankrupt a country to do it, but if it's a small fraction of the GDP, I think it's better than the way we spend some other fractions of our GDP, okay?
Thank you. Back in the time of Apollo, US manned space budget was getting up to about 4.5% of their GDP. It is now, NASA's budget is 1/3 of 1%, and human spaceflight is about 50% of that. Whereas American spending on Medicare is over 30%. So if you put all that money into Medicare, nobody would notice the difference. And there are other areas of the US budget, which are even bigger than that. And if you compare what we get out as results from the manned space program, I would say it's certainly worth the money. Any more questions in the room?
I have a question about space debris. I'd like to know your thoughts on it.
Mike, I have a lot of thoughts about it. It's, sorry, do you want to, I can pick it up from there if you like.
Well, the question was, I read some space news about it, and some people say, there's a risk of Kessler syndrome and the risk of collisions is getting higher, and countries don't seem to be focused on cleanup that much. Are they right to fear, or is it being a bit overblown for clickbait headlines?
Well, nobody, I mean, the Kessler syndrome certainly is a feasible event, but nobody's worked out the threshold satisfactorily. So we, at the minute, there's nothing like that happening. On the other hand, my feeling is there should be regulation, and indeed, the problem we have is the US doesn't want it, or at least certain influential people in the US don't want it. Europe is about to introduce a regulatory system, which I think is very clever. And we in Britain, whether we like it or not, despite our freedom from Europe, as long as we want our companies to work in Europe, we'll have to follow the law. But, and indeed, American companies will have to follow the law if they want to use their systems in Europe. So it's a very clever idea what they've come up with. It should come into being within the next year or so. The plans are all put together. I think that's the way to do it. It's got some admiration outside Europe because it is the only way. The UN has no power to regulate. So you've got to do it in the way that, say, the American president is doing things, by simply hitting people's pockets and affecting the market. And that's the way this is going to try to introduce regulation. That is, you won't be able to operate selling services if you don't have a sustainable, clean system. It's a very clever idea, in my view. It's not popular in the United States with certain very influential parties.
No object. What project or program would you like to push for and see happen?
I get asked that question. As a matter of fact, I think for somebody with an interest in engineering, money as no object isn't that interesting. The challenge is to do something effectively and efficiently and for a price. That is, to meet the boundary conditions but the short answer to the question is, I would like to get Rosalind Franklin down on Mars. Okay, I mean, that's my, and it actually wouldn't cost that much. I mean, we're talking, probably need, I would say, to be safe, €500,000, not pounds. But we don't have it. We had got an arrangement with the Americans, a trading arrangement, but in the present situation, we don't know whether that's going to work. And it's simply because of the American money. So there you are, that's the best I can do. Okay?
Any online? No. Okay, 2028.
Sorry?
2028, latest date, Rosalind
Yeah.
Franklin. We'll see. Okay, well, I'm sure you've really enjoyed what you've heard this evening. And as you've discovered, David is my top speaker designate for this year. And the reason he can't make it in June is because he's going to be at an event at the European Space Agency.
50th anniversary.
There we go.
It's the 50th anniversary of the European Space Agency this year.
And there's
June the 12th, which apparently is when you're meeting, is the day we've chosen to celebrate it.
Yeah.
And I'm afraid, much as I love being in Hatfield, I've got to say, you know, Paris is full of French people, terrible place, but I am loyal to ESA.
And there is, I think, still a possibility that Roy Gibson, who is 100, who is the original director of the European Space Agency, may be present.
He'll certainly be invited. I'm not sure he can travel that far. I'll tell you somebody else you may, I don't know if admire is the right word. Michael Heseltine has been invited. Michael Heseltine, in some ways correctly, claims to be the inventor of ESA. It's not quite true, but then what most politicians tell you. But he's right that he actually played a pivotal role in breaking the deadlock back in about 1974, the spring of 1974, when he proposed the optional program system, which is used to this day. He's very proud of it, and I think he's every reason to be proud of it. But I think the agency was going to happen whether or not he improved it immensely. And he's very proud of it, and he definitely is being invited. Roy Gibson will be invited. Roy lives in Bath now, but I think he will say that travel is too difficult, so he'll probably join us remotely, you know, by a link.
Okay, so once again, David, thank you very much indeed for this evening, and I'm sure all of you would want to show your extreme appreciation.
I have to dash off because,
Okay, just our last closing remarks. What a remarkable talk that was, wasn't it? Absolutely brilliant. A reminder, Hagas for the Astrophotography group on April the 23rd, they've got an open meeting. So if you want to come along to that and share some of your experiences or ask your questions about taking some of those wonderful photos that we saw earlier, that will be a good one for you. And on May the 28th, they've got Glenn Clowder coming along to speak to them. Those dates will be notified to you on newsletters, but in case you want to make a note of them now. So that takes us to our next meeting, which is on May the 14th. We're starting the meeting slightly differently. Instead of our talk about the night sky, we've got our annual general meeting. Yeah, I can see the excitement on your faces already. We promise you, we aim to make it no more than 15 minutes. If it's longer, that's up to you. But we aim 15, 20 minutes perhaps to have the AGM. And then that's followed by a talk called Light Bending in the Sky by Alan Heavens. So that's going to be in your diaries, May the 14th. All that needs to be said now is thank you very much indeed for being a wonderful audience and coming along. Super questions. This is a great talk. And of course, my thanks to everybody who made this evening possible. John, for that lovely talk at the start there. Obviously, our technical team, thank you for sorting out all the bugs and gremlins we'd got there. To our membership secretaries, all the other bits and pieces that go on in the background to make these meetings possible. All that needs to be said now is thank you again for coming. Have a safe journey home, and we look forward to seeing you soon. Bye-bye now.